Hey, what's up, everybody? This is Papa Bale, and welcome to the channel. I was somebody made a request of me to draw a picture of what I'm doing in the other room with my mama pulse motor and baby pulse motor. This is a description of what it is. Two motors. All they do is spin. Okay, electrical to mechanical energy. All they do is move. That's it. No load. No load. I'm not trying to prove anything right now. So it's just, they just spin. That's all they do. All right, so we're going to start at the power supply. Let me zoom in a little bit. Okay. PS, power supply. This will be somewhat reminiscent of the setup in the room back in the back. Connect your power supply to your power distribution. I have an Eve model power distribution, which has 10 positive and 10 negative receptors. 6 of them were used to hook up this coil, which has 2 strands for baby pulse motor, 28 gauge and 26 gauge, 666 turns of each. And then the other end of those coils are connected to their own, or those strands are connected to their own transistor, which is hooked up to a Hall effect sensor via the base. And you got one Hall effect hooked up with the little bows like that. That's where the Hall effects are hooked up. So that's one Hall effect and one coil. So these first 2 connections, first 2 go to the coil, and then the Hall effect sensor goes to that one as well. The next 2, the negative, the transistor emitter is connected to the negative terminal of the power distribution block. And then the next 2, we're going to follow those over here to Mama Pulse Motors coil, which has 3 strands in it of 32 AWG at 333.3 turns a strand. One strand is run separately and 2 strands are run together. They each have their own tip 42, so you have a single strand and a series strand run through the coil. And then you have your Hall effect sensor on your rotor, which has 9 N52 all north. And then, of course, the emitters are connected down here to the negative terminal of the power distribution block. And then the other bow, the last slot here next to the description, is the Hall effect sensor, which goes up. And I screwed up. I put the Hall effect sensor on the coil, but it goes up here. So you can see how I just connected the base connections to the Hall effect line. Probably have simplified that even more, but I'm drawing the picture. So, and then I'm going through all this trouble to explain it. So I don't know, man. Can't help you if you don't get it. All right, and both of these will run pretty good at around 18 watts, I want to say. I mean, you can get them running at below a watt. Well, no, actually, I think it's around 10, around 8 watts, I want to say. 10 volts and 0.8 amps. It's when everything kind of kicks on and gets moving. But since we only have one power source for both of these motors, it does the best it can to regulate. I mean, it does have some regulation built into it. The power supply does. So when all these transistors from the different motors are kicking on and they all have different needs and everything, this power supply will regulate that as, okay. It won't do like a superb job, but it'll make sure you're not blowing too many amps unless your wires are crossed, and then you're screwed. I think it's really awesome. I mean, we got baby going up around 1800 RPMs, and we got mama over here going around 750, 800. It's really, really neat. There's no trick here. It's all hooked up, solid as a rock. All right. Thank you very much. Peace out. Have a good night. Please subscribe. Bye now.